Hello, everyone. As a core component of a machine vision system, industrial cameras types and performance parameters directly affect the quality and efficiency of image acquisition. So, what are the characteristics of the different types of industrial cameras? And how do the performance parameters influence their practical applications? Today, we will delve into the topic types and performance parameters of industrial cameras and unveil these mysteries together. This lesson will mainly cover the following two topics. It is hoped that through this lesson, you will achieve the following objectives. First, let's understand what an industrial camera is. An industrial camera is a key component in a machine vision system. Its fundamental function is to convert light signals into structured electrical signals, ultimately resulting in digital data. Industrial cameras are mainly classified into 4 categories, based on signal output type. They are divided into analog cameras and digital cameras. The main advantages of analog cameras are their broad compatibility and low cost, while their disadvantages include generally lower resolution, slower acquisition speed, and susceptibility to interference. The primary advantage of digital cameras is that they integrate an A to D conversion circuit internally, which directly converts the analog image signal into a digital signal. They feature strong anti-interference in image transmission, a variety of video signal formats, high resolution and rich video output interfaces. Based on the imaging method, they are divided into area array matrix cameras and line scan cameras. An area array camera is a camera that uses a pixel matrix to capture images, enabling the acquisition of an entire image at once for timely image capture. A line scan camera uses a linear array image sensor and is suitable for scenarios where there is relative motion between the measured object and the camera. In operation, the two acquire images differently. A line scan camera captures one row of pixels at a time, whereas an area array camera, when triggered, acquires an entire pixel matrix. Based on the image sensor, they are divided into CCD and CMOS types. A CCD camera refers to a camera that uses a CCD as its image sensor. CCD, which stands for charge-coupled device, is a detector that represents signal magnitude by the amount of charge and transmits the signal via a coupling method. And it offers advantages such as small size, lightweight, self-scanning capability, a wide spectral response, minimal imaging distortion, low system noise, fast response speed, low power consumption, long service life, and high reliability. A CMOS image sensor is a typical solid-state imaging sensor, usually composed of a pixel array, row drivers, column drivers, timing control logic, an A to D converter, a control interface, a data bus output interface, and other components. And it features random window readout, strong radiation resistance, high reliability, a simplified hardware structure, non-destructive data readout, and low cost. Based on imaging color, they are divided into color cameras and monochrome cameras. A color camera refers to a camera that captures images in full color. A monochrome camera refers to a camera that captures images in grayscale. Next, let's study the performance parameters of industrial cameras. There are mainly 8 items. 1. Resolution. Defined as the number of pixels along the width of the sensor multiplied by the number of pixels along the height of the sensor. The commonly heard specifications such as 2 megapixel camera or 5 megapixel camera refer to the nominal resolution of the camera. Resolution affects the quality of the captured image. For the same field of view, a higher resolution makes the details more distinct. With the same pixel size, a larger sensor area implies a higher resolution. 2. Pixel depth refers to the number of bits used to store each pixel. The more bits used per pixel, the richer and more nuanced the color, resulting in deeper color depth. Resolution and pixel depth together determine the storage volume of the image. 3. Sensor size refers to the physical dimensions of the light-sensitive portion of the sensor. The sensor's diagonal length is approximately equal to the labeled value, in inches, multiplied by 16 millimeters per inch. A label such as 1/1.8 indicates that the sensor's imaging area is roughly equivalent to that of an image intensifier tube with a 1/1.8 inch diameter. The sensor size is an important factor in lens selection. 4. Pixel size refers to the physical dimensions of an individual pixel on the sensor, given as length multiplied by width. Pixel size and pixel count, i.e., resolution, together determine the size of the sensor area. For a sensor of the same size, a higher resolution means smaller pixel size. Image quality is directly proportional to the size of the pixels. This also means that for sensors of identical size, if the resolution is higher, the pixel size is smaller, which may lead to poorer image quality. 5. Maximum frame rate/line frequency refers to the speed at which the camera acquires and transmits images. For area array cameras, it is typically measured in frames per second (fps). For line scan cameras, it is the number of lines acquired per second (hertz). 6. Shutter mode and shutter time. For line scan cameras, exposure is done line by line, and they can operate with either a fixed line frequency or an external trigger for synchronous acquisition. Area array cameras offer several common exposure methods, such as frame exposure, field exposure, and rolling shutter exposure, and usually provide external trigger functionality. Industrial cameras generally have shutter times measured in microseconds. 7. Signal-to-noise ratio, an indicator used to evaluate image quality. The higher the SNR, the better the image quality. It is measured in decibels, and modern industrial cameras typically have an SNR between 30 and 55 decibels. 8. Lens interface type. The type of lens interface is independent of the quality of the camera or the lens. Lens interfaces are classified as either threaded or bayonet mounts. The C and CS interfaces are the most common international standard interfaces for industrial cameras, corresponding to a 1-inch, 32 UN imperial threaded connection. Everyone, today's mini lecture is coming to an end. In this lesson, we not only gained an in-depth understanding of industrial cameras, but also thoroughly discussed their performance parameters. We hope that you will apply the knowledge you have learned in practice and contribute your strength toward building a robust nation in intelligent manufacturing. Let us remain true to our original aspirations and forge ahead with determination. This mini lecture concludes here. Thank you, everyone.